All right, looks like it's the top of the hour. We're going to kick it off today. So we're going to try our best not to run this like a typical webinar, right? We are not going to go through all the slides and wait to the end for questions. Like, don't want to do that today. We do have a lot of topics that we do want to cover. But the core around this is around like this configuration management problem. So the title of today is The World Without Configuration Chaos. I'm joined by the Q Labs team. This is the team behind the open source project Q. They just had a recent announcement of their company coming out of stealth, funding and all of that, mainly to talk about some of the gaps that are left behind by current tooling or even Q itself. So I encourage everyone to keep this super interactive. If you have a question, use the Q&A. I will scan both the Q&A and the chat for any of the questions, and we're going to take them and answer them in real time. Before we get kicked off today, I am joined by the Q team. Going to have people introduce themselves. We'll start with Marcel, Paul. Maybe give people a little bit of background on what you were doing before starting Q Labs and what you're currently doing at Q Labs. We'll start with you first, Marcel.
Yeah, hi. I'm Marcel. So I'm the creator of Q. It started at Google as a 20% project, really to improve some of the, in my view, errors I made with the system, the GCL language that I created for Borg. So I was on the founding team of Borg, later on the Go team. And basically, that was over 20 years ago now. And we've learned basically a lot of things that we could have done better. And that has now culminated in Q.
Awesome. And just for those that don't know, I think Google and Borg config, you're talking millions and millions of lines of configuration code. So if you're used to Puppet, Chef, and Ansible, multiply that by a factor of God knows what, and you end up with all the problems you could ever imagine when it comes to config. So it's really great to have someone like Marcel on the founding team. Paul, you're next.
Thanks, Kelsey. Hi, everyone. My name is Paul. I met Marcel back in 2017 when I was giving a talk at a Go conference. I was talking about some sort of UI system that I'd created then, and Marcel very kindly came up and introduced himself. And known each other since, but it was in 2019 when he said, "Oh, hey, I've got this thing to show you." When I was working on a financial modeling platform of all things, that Marcel introduced me to Q. And I can actually distinctly remember the conversation because I burst into tears thinking, oh my goodness, we needed Q, the technology, for what it is we've been building in the financial modeling platform. And so started my journey with Q. And Marcel and I started working together. And that sort of was then the idea for making Q into a thing outside of his time at Google and trying to bring the power of Q, the open source project, to everybody. And as Kelsey said, that culminated in the other day with us announcing what it is we're doing with QLab. So really excited to talk about the configuration control plane and that vision for how open source Q can sort of be taken to the next level.
Awesome. And I think the last person we have on the call today from the Q team is going to be Dominic. If you do want to introduce yourself, and then we're going to kick things off.
Sure. Hello, everyone. Thanks for joining here. And yeah, I hope you have a great time and insightful time. And you have any question afterwards, we're watching the chat. You can now mail us at any time. We will share the email addresses after this call and enjoy.
All right, Paul, you're going to drive the slide, so we can pop over to slide two. So, really the big idea is the configuration chaos. Now, the thing I want to explain clearly here, everyone has their preference of configuration management tools. Sometimes I looked at there's corners of LinkedIn where people are arguing Pulumi versus Terraform versus Puppet versus Chef versus Ansible. That's not what we're doing today. We think that there's going to always be a preferred set of configuration. And the reason why I think this is the reason, or the reason why I think this is so, is because I think configuration is the part where no matter how much tooling you have, humans have to make decisions about how their apps or their infrastructure runs, right? So all those knobs and features and options that are exposed by your database, your server, your applications, your firewall, your router, at the end of the day, that stuff becomes configuration because we all know that none of these platforms come out of the box in a perfect configuration for every single person and for every scenario. And so in that world, you're just going to end up with a bunch of configuration. The other thing that you may not realize is that I even think about things as like the JVM settings. So if you ever run a Java application, you can pass the JVM a bunch of command line arguments. To me, that is another form of configuration. So it's not just the things that you get from Terraform or from Kubernetes if you have experience with those tools. Configuration lives in lots of places, and that's what leads to this configuration chaos spiral. There's a bunch of hidden configuration that doesn't get it treated that way or articulated anywhere, and it comes to bite you in the worst cases. That's what today is all about. That's kind of what the whole Q team has been working on for a couple of years now. Next slide. And we're going to get into, if you've been using Q, you probably already know this. For people that are that advanced in their configuration journey, they've already been using things like open source Q to kind of fill this gap. And I think, Paul, if you could explain the next slide to give people a little bit of an overview about what Q does, and Marcel, happy to jump in as well, about what Q does for people that are using these existing tools.
Yeah, absolutely. So Q, for those who aren't familiar with Q, Q is an open source language. It's a set of tools that act as a powerful logical engine for configuration. And what that means is that Q brings together a number of separate concepts under one under one hood. So Q enables you to work with data, just like YAML or JSON. It also enables you to work with schema, like JSON schema. It also blends in the constraints, rules, or contracts that you want to enforce in your configuration, as well as allowing you to specify that as policy and doing things like templating. So for those who would be familiar with templating languages, whether that be within Go itself or things like Helm, Q brings all of these things together under one hood. This is all part of the open source project. So for those folks who are interested in giving it a try, you absolutely can do that today. But really, the gap that we're talking about today is Q doesn't do all of these things for you. Q is a very powerful tool, but it's not a complete system. And so Q doesn't, out of the box, open source Q doesn't by itself allow you to connect to your PRs, create an audit trail, for example, answer the question, what happens if we change this value? It's got the building blocks for it, but it suffers in some respects from this plumbing problem. As an open source project, it's only going to go so far. So that's really the focus of what we're talking about today. What fills that gap? How does Q become production ready?
And when I met you, Marcel, I think the one thing is, someone who was deep in the Kubernetes world at the time, when you look at Kubernetes, I think it's a departure from configuration as code into configuration as data. And you just look at one of those YAML files. Maybe we skip over to slide 6. And that's a couple slides from there. If you look at slide 6, a lot of people in the Kubernetes world see this and say, hey, great, this feels like a step forward in some ways where we can kind of declare without any code, if statements or anything, that, hey, I would like this Kubernetes cluster to run one copy of Nginx, and I can commit that to a Git repository, and then Kubernetes runs it. And I remember meeting Marcel, and he was like, well, what's going to eventually happen is people are going to turn this into templates, right? Because there's a lot of boilerplate here. If you can look at this, you see we're specifying almost the same thing multiple times in multiple places. Of course, you can use a linter to kind of catch some of those things. But I think Marcel already predicted that people will probably come up with things like Helm charts and case sonnet, and there's a bunch of tools around this. And there's another problem. How do we know that this is correct? How do we know that replicas can't be the value of 500,000? You could actually type that in there. Kubernetes would accept it, and it would try its best to give you 500,000 copies of Nginx. And this is where most configuration languages or tools come out, and they hardly ever have verification or validation built in. And this is something that you saw for a long time, Marcel. Maybe talk about this problem and how Q helps with it.
Yeah, so Q, it's not just a templating language, it also validates, and it basically does so by unifying values, and types and constraints into this one big space, if you will. And one important thing, so what was, where you see a lot of languages go wrong a bit, is that configuration is quite a different beast from normal software engineering. So normally you have all these things that you basically smaller components that you put together into big components, and overrides kind of make sense there. I know I was on a Go team too. They say don't do that, right? But no subtype inheritance, but still it generally kind of works with software engineering. But with configuration, first of all, the objects are often very abstract, so it's very hard to see what's the thing that really corresponds to the real life. And second of all, there's not a natural ordering. So you have policies coming in from all these different organizations. Like the SRE team might say you have to monitor, you have to set up monitoring in a certain way. There might be another team that says we want to limit the number of replicas. And you cannot say that one takes precedence over the other necessarily. They all matter. And what Q does basically is a way of defines a way of combining these things that are order independent. And this is really where this chaos or complexity comes from, right? Like if you have to define the order, things just get completely out of hand. And Q allows you
And go
to.
to the next slide. And I think what you all will see is pretty much when I started configuration management, this is around 2012-ish, actually 2009 in production as a practitioner. But when I went to go first work for Puppet Labs, what I saw was Puppet, Chef, Ansible. These days we have Terraform, Helm, Kubernetes itself, things like GitHub Actions, or some random configuration language that you build on your own. We end up creating dedicated tooling for each of these things. And it tends to make sense, right? If you think about the case of Terraform, Terraform is HCL, so you would actually have to understand HCL itself to some degree to then build a validation tool for it. And then you would have to repeat this process across every configuration language, something that knows the language well, and you would then have to expose some type of policy engine, some type of maybe separate DSL to allow you to describe what each of these fields can and can't do. So for those unfamiliar with validation, in that last example with the replica count, we know that that's an integer. We know that it may have to be positive and never negative, but your company may say, we will never run 50 copies of anything. Anything more than that needs a discussion. So then you can imagine using some validation engine to say, look, if this deployment specifically has more than 50 things, then make it fail before it gets to the cluster. And to be honest, most people are not doing this. You might be doing this in maybe CI. You might be doing this as an emission controller in Kubernetes if you're used to that. But usually there's a big gap here. And if you go to this next slide, this is what I think Marcel was kind of hinting at, is this idea that what if we turn this stuff into schemas? And this is the part where I know most people have a lot of questions about the type of work that's involved to get into this world where you can actually have something like Q become a validation engine. Maybe the Q team, can you speak to the step of like, why do we need schemas first, right? Like you're like, hey, I already have a schema. Kubernetes understands it. Why do I have to create another one?
Yeah, so I think I can jump in here actually. I think the previous slide is actually quite useful in this respect here because is the problem of having separate tools for each of these is that, as you say, Kelsey, we need to perfect those tools. We also need to hook them up wherever we're trying to validate things. And instead, what it also creates is it makes it very difficult for us to do validations between these different configurations. And we'll come to talk about that point later on. Excuse me, jumping around there. What we have here is this is the Q command that is trying to show how we can validate with things with Q. And here we're actually using a schema that has been published to the central registry as a way, as a one-liner of validating an existing YAML file. So we've taken the config where it is right now. We're not saying to someone, you have to convert this to Q. The actual configuration file itself is still in YAML. And so Q and it is able to speak these different languages, these different data dialects, as I said, YAML, JSON. And so here it's natively able to use a Q schema to validate this YAML. And the idea behind sharing schemas that represent our sort of consensus, if you like, amongst the authors of software as to what represents a valid configuration, at least as much as we can validate. And that's a really good state to be in, as you said, Kelsey, because that shifting left means we can catch problems early in that authoring cycle before they get sort of expensive down the line. Worst case being we actually deploy something invalid to production. So schemas are really the basis for that shifting left. And on top of that, we can build things like policy, as Marcel talked about.
So for a lot of people, I think this is the part where we get a little bit more mature. And so there's a question in here, can Q speak Engine X? And I think this kind of links to this thing. So maybe Paul or Marcel take a stab at that. Can Q speak Engine X? And maybe what does that mean? Engine X has its own config dialect. I've written lots of Engine X configs over the years. It's very peculiar. It almost looks like a custom DSL. Can Q help with something like Engine X?
At the moment, not. So we have a similar issue with HCL, but HCL has a conversion to JSON, right? And this is how Q usually deals with it. So if there's an Nginx to JSON converter, for example, we would be able to deal with it. Um, we are working on making this pluggable though, so that you can easily add your own support for dialects.
But I think it's very often the case, Marcel, that as you just said, tools like Nginx do not only consume their native format of
Yeah,
configuration, but additional formats. And you pointed Terraform to Terraform as a good example there. People who write Terraform configs may be very familiar with using HCL, but there is a JSON format of that, which is equivalent in terms of if you feed that to Terraform, you're driving Terraform in exactly the same way. So the idea behind Q is that you shouldn't have to change your existing configuration, and we should be able to translate that. But if not, the open source project, that's the whole point of these. If there's a very popular configuration format, absolutely open to adding these things to the open source project. We've even had companies approach us saying, hey, we have this custom internal configuration language, as you said, Kelsey. And in that situation, writing these sorts of encodings in Q, it is very much a sort of a bread and butter part of the Q project itself.
Yeah, I spoke at an HA Proxy conference maybe a couple months ago, and HA Proxy also has this problem. They built a very custom configuration language. Remember, a lot of these tools like Nginx, they're written C, they're written a long time ago, before we had things like JSON or even XML was super popular. And so they built these things that were friendly to parse via things like the C programming language. And so what you end up with is a world where these are very friendly for the parsers that they had to write by hand or that were native to those particular things. And they were also a little bit easy for a person to write, but they only worked for one particular tool. In the case of HA Proxy, they saw this as a bit of a problem. And so what they did was they actually built a shim on top where they can actually take JSON in natively for something like HA Proxy, and then they convert the JSON to the native configuration language. So someone mentioned in the chat, Caddy takes in JSON natively.
Yeah.
I know Nginx Unit, which is kind of like the next generation of Nginx that works well in a service mesh, works well in a container or Kubernetes type environment. Nginx Unit, so the same team that created the Nginx you know and love as a proxy, the Nginx team also has the ability to bring in JSON that way. So Nginx Unit, I don't know if that's going to ever replace Nginx the proxy, but I think we're starting to understand that having data representations of configuration to complement your DSL goes a long way, especially when you think about the nature of processing the configuration file. You're going to have to turn it into some object model, the programming language that's using the configuration understands anyway. So I think we're going to see more of these tools move towards a data representation. That way, we don't have to rebuild all of these language parsers first and then have those translate into something that could be treated more like data on the back end. So I think you can see from this slide here, a lot of the, I would say more recent configuration tools like Terraform. Terraform itself has HCL and a JSON dialect, so you can use either one. Kubernetes, of course, actually has protocol buffers internally, but it supports YAML and JSON on input. And so I think that's a really important component here. There's this movement, infrastructure as data. I remember talking about this about 10 years ago that coming from the world of things having Ruby DSLs, even though they look cool, they're very powerful, they are not interoperable between any other tooling, and it's almost impossible to build validation engines in them unless you implement the whole DSL. So we're moving away from that, and I hope tools like Nginx follow at some point. And I think someone also followed up here is that things like Nginx are also coming up with APIs for configuration, meaning you can post a JSON blob to them and then they will actually do runtime configuration. So in many ways, that's more in line with what Kubernetes is doing in terms of taking JSON objects and then running an internal configuration based on those things. So that's what Q is about, saying once we have a schema for those things, then Q can do its magic. So far, I think we've all been talking about using Q as a layer above your existing configuration management tool. So keep those tools. And then ideally what you do is you use Q and its backend schemas to do things like validation. And if you want strong validations, you can do things like, hey, no more than 5 deployments on anything, and then Q can return errors when you violate that particular policy. There are a couple of questions. I'm going to bring those in. Can you demo a typical example where Q shows its current value. And maybe we have a slide that speaks to that. It's okay, we have to pull up a website, but that's the particular question. Can you demo an example where Q shows its current value?
Yeah, I'm not entirely sure I follow the question, but this is actually it may be a good segue into these next slides here, because what Q enables you to do is there's two parts to it. So let's just first of all take a look at this example here, which is coming back to what Kelsey pointed out earlier on. Excuse me. There's a good deal of repetition in this configuration file here. And let's just assume that, as we know, that we need this value example1 to be consistent between all these places here. Now, as humans, it's actually a very good way to be able to communicate that restriction between ourselves because we'll understand it better rather than sort of trying to reverse calculate that from for want of a better phrase, from the configuration itself and then validate that it's the case. So with Q, we can do just that. So the top right-hand version here of example.yaml is that much reduced form. So here we can just see the key parts of this configuration really dried up here. And below it, we then have this Q that represents that rule, effectively the templating that says, well, these things must be consistent. So I think the question of what is the current value of Q comes from the fact that Q can actually be a sort of a partial representation of something with not all its bits filled out here. So if you combine the two boxes on the right-hand side using Q, what you get back is the exact configuration you see on the left-hand side. And what that means is that in some situations you can be left with gaps in your configuration, and you can fill those in later using using additional unifications in Q. For example, if you late bind in secrets, for example, you don't necessarily have your secrets up front, and you want them to be added later on. So this is actually one of the sort of the key gaps that we're talking about here with the Q open source project, is that when it comes to productionizing these things, you want to visualize, as I think the question is hinting at, what the current value of something is before you merge in those secrets in some way, shape, or form. So you can do that using the Q open source tooling. It's just not very production ready. And that's sort of, again, part of the solution that sort of fits into that gap there of how do we get Q production ready.
Marcel, could you do a walkthrough of that bottom block there, right? Because for a lot of people that have never seen Q before, this is probably going to be something new to them, right? So it makes sense to think at the
Yeah.
top, a very snippet of Kubernetes, but it doesn't have all the right things in there. It's missing some bits to make it a valid config, and you combine it with the Q below. Maybe walk us through line by line.
Yeah. Yeah, so the bottom right block basically also gives you a little bit idea how QOP will work. But the general idea is that if you have a whole bunch of Kubernetes objects and different objects, you put them in within one namespace within Q. So in this case, we're saying we're only dealing with Kubernetes, so there's no Kubernetes at the top, but you have a namespace production. Then we have a bunch of deployments. The square bracket string means all deployments. And then we say all deployments must conform to the app's deployment schema. That's the schema we saw earlier on the command line. And then we're basically saying, so all the elements that are repeated, I see there's some indentation issues in the left block and the upper left block. But basically, in all these orange labeled things, so first we mark metadata X, that's an alias, and then we're basically saying, okay, we refer to that alias and we repeat the name, metadata name, in all the places where it needs to be. So we basically say you only have to specify example once, and then we repeat it at all these other places. There's different ways to do it in Q, but for this example, we've chosen this way of doing it. So now there's two ways to use this. So you can say this is this could be a validation tool, right? So basically, if you run your YAML through this, you place the YAML at that spot. There's on the command line tool, you can give arguments to basically place it there. And if you place it there, if any of the example, if for example match labels app would be not example one but example two, that would be resulting in a conflict. So that would be a failure, right? So this becomes now a policy, if you will. It basically says selector match label app has to be the same as the metadata name. Um, Now, basically, so this is not supported yet for YAML, but we do intend it in the future. This is only supported for Q right now. But there is a tool called Qtrim where you can say, okay, fine, we now have this policy, but we actually now want to get rid of the boilerplate. So Qtrim allows you, as I said, right now just for Q, in the future also for YAML, allows you to basically then remove all this boilerplate. So you can start with your setup and basically say, okay, we just want to have the validation rules, warn us if everything goes wrong. But if we're confident that our validation rules, our policies are correct, we can start saying, okay, now start removing all the boilerplate from all our configurations. And that's an automated process. Um, and there is a demo online and also in the Q repo, the Kubernetes demo, where you basically see you go from 2,000 Kubernetes YAML lines of YAML to about 1,000 within like 10 minutes, right? So it basically, by specifying a few templates, you shrink the whole thing down. So this is a little bit of flavor of what Q can do.
The thing that I think is so important about this, configuration tends to be the last thing you want to do or touch. And the less that people have to look at, I think the more focused they can be on the things that are actually important, right? When you start having 100 lines of YAML files to stare at, and you only care about two or three fields, this is when people either start making mistakes or things don't get updated, right? Like when something is deprecated or you don't want people to use a particular field anymore, the cleanup necessary to go through every repository and remove things that are don't fit the style guide or not the way you do anything anymore becomes so laborious that most people just don't do it. And I think in this scenario, shrinking these things down to say, hey, we're getting closer to the API we want developers or operations people to use, and then the policy drives the rest. Think that's like the key to any platform engineering is to say, what is the absolute necessary API we want people to interact with, and then
Yeah.
remove everything else to policy. The other part here that I think was interesting is I was like, oh, great, a better templating engine. The other thing I think that you mentioned, Marcel, is that there's a bit of validation that's happening under the scenes here. Like if I'm trying to put in a number instead of a string, there's additional things that Q is going to
Yes.
catch that I may not catch by hand. Maybe speak a little bit about some
Yep.
of the free validation we're getting here.
Yeah, so the apps.hash deployment, hash basically means it's a schema. So that's really the thing that makes it typed here. So by default, like most configuration languages, YAML and JSON, for example, there's no real typing there, right? So for a field, but with these schemas, you incorporate the typing. And you can define schemas at a central spot. You can, like elaborate on the schema or add more policy. So basically, these schemas can be as precise as you need them to be, right? And they can be, um, um, yeah, basically not just types, but also ranges of values, or basically say this should be a certain, string of type URL, or what have you. Yeah.
I'm going to read some of it's like a lot of testimonials. So there's a lot of people who are using Q, seem to be getting a lot of value. So in the chat, there's a ton of people just talking about how they're actually using Q. So before we move on, I'm going to go through a few of these because I think it's kind of important. You know, it's one thing to hear from the team that's building this. Of course, they're a little biased. But when you hear from people that are actually using this in the field, I think that's where we get the most signal from. So first of all, one of them I think is from Kai. With Q, configuration is no longer a means to an end, but continually refactoring abstractions is a breeze and a joy. It's when I caught myself smiling ear to ear one evening while writing Cube application abstractions. I realized just how awesome Q was. Native LSP, probably like language server integration to your IDE or CRD support, really was the final step before adoption for us. And I think for a lot of people, Kubernetes is daunting out of the box because you're giving people a huge API surface and you're expecting them to learn what all of these things mean, even the boilerplate stuff that is really only there for Kubernetes or internal components. Being able to do something like in the top right for your team, you're crafting this API, you're putting in validations. So ideally, even if someone knows Kubernetes, they can come in and not have to learn the way you use Kubernetes for this example. And I know we keep talking about Kubernetes quite a bit here, but the goal is to do this across lots of configurations.
Yeah.
Honestly, the thing that has me excited about the call today, and actually even the Q team, as someone who's advising the team, why do you believe that this is going to work? When people ask me those kind of questions, They're solving a grander problem. And so if we were just talking about Kubernetes configs, there's ways you can do this. Kubernetes itself has the validation engine built in to some degree. There's emission controllers, but you don't have all of that across the entire
Yeah.
configuration landscape. And I think we should start progressing to that part of the discussion
Yeah. I
around some of the validation stuff. Go ahead, Marcel.
Yeah, I have a very nice example there. So, for example, there was one trading company that has future contracts, and these future contracts also have certain regularities in there. And this is a pattern I've seen with Kubernetes, but just the exact same pattern there, where you start out with layering queue validations on top of their YAML. They had their contracts encoded in YAML. And you basically get off the bat a whole bunch of errors. So some of that is me encoding the rules wrong. That's about a third. Then a third of it is you immediately catch data errors, and they can be very costly with trading companies. And then one third of it is usually so the rules are correctly encoded, but the business misunderstood their own rules. So you basically see sort of holes in their way of thinking about the business, right? And this is with 1 hour exercise. You basically solve a whole bunch of data problems and expose like problems in their thinking about their model, which is quite nice to see. And this is quite consistent if you apply Q that way.
Let's go to slide 12. This is another classic example. I remember the thing that I love about Kubernetes was this whole configuration as data, as we spoke about before. But the thing that that data does is like you can do static analysis on this file, but there were no static analysis tools in the very beginning, naturally, right? It's a new product, it's a new thing. And a lot of that validation gets moved to the server. And so when you think about it, one of the validation tools that was built in was things like the limit range kind of policy or type. And what this says is like, hey, the max memory that a container could use is 1 GB. And so another team may put this into your cluster. So you may be unaware. The DevOps team says, hey, people are using way too much memory per container. From under the hood, we're just going to apply this to the cluster. So now it's sitting there. Now, the good news about this approach is, regardless if you have self-service or CI/CD is pushing things automatically, you have no idea what people will do to the cluster, but at least you have this kind of gate there. You have this kind of safeguard in place, if you will. And so if someone comes up to this Kubernetes cluster and says, hey, kubectl applied this deployment that I got from some random place, or maybe I don't know what the policy is, they're going to get this immediate feedback of, hey, 16 gigs exceeds the 1 gig max limit. Now, the challenge with this is you got to go try to figure out where this is coming from. So if you're not familiar with namespaces or how Kubernetes lays out, you may not even know what a limit range is and what it does. And so you're going to have to do a bit of investigation to figure out why did this not work. The last thing you want to do is get this error when you're trying to go to production. So QA, it works. The staging environment, it totally works. But in production, it doesn't work. And now you're thinking there's something either wrong with the config or the cluster, right? And this is the thing that starts to become this gap in terms of this consistency in terms of what you think is going to happen. If you go to that next slide, I think this is where the game starts to change in terms of, we talk about this all the time, Paul, around some of the value that Q brings. So maybe explain this a little bit to people.
Yeah, so it's not at all to undermine the value, as it were, of the previous limit, the memory limit on the previous slide, but it's also to just show that it, as Marcel said, you can build on top of the schema to actually also express constraints on what values fields can take. And here again, we're focusing on the deployments as just an example, building on this Kubernetes example, where in Q itself we can enforce this sort of restriction. And the benefit there is that it again, so we talk about configuration being this consensus building thing, whereas Marcel said you might have the platform team saying, no, 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 in production, you really cannot have more than 1 gig here. Expressing that as a policy in a way that can just sort of be chucked into this bag of rules and constraints that can be applied. As Kelsey said, what you can then do is you can trace that back specifically to the team who actually specified that policy. And more than that, as we'll see later on as well, you can start to express these sorts of constraints between different configurations. And so Q having this sort of overall view of things with this combined power of sort of having policy as well as just type constraints, saying rather than just saying, oh, this field has to be a number, you can actually start to combine in these constraints. And that then really becomes the superpower where we go beyond having to have these sort of late time checks that are perhaps applied by a different system. Again, we're shifting left with this kind of stuff.
The other thing I hope people take away from this is that while that range limiter for things like memory are great, what about every other field?
Yeah.
It could take forever. I don't even think the Kubernetes community will probably have the bandwidth to do it. But trying to do this piecemeal for every possible field, look, maybe it's possible for the native types like a deployment, but Kubernetes also has another killer feature, I think, which is the ability to have custom resource definitions. So these are the definitions you make on your own. And now you're in another situation where no one's going to build validation engines for those. And if you try to do it the way Kubernetes wants you to do it, then you would basically have what we call emission controllers. What leads me to kind of my next question, or maybe something that was highlighted by, I think, Maximilian said, hey, it would be dope to have a queue emission controller, right? You can imagine people wanting to do validations like this for a range of configurations. I see Marcel smiling there. What do you think about a queue emission controllers? I'm going to give you two challenges. Number one, how would you do it today? And then what is your team kind of working on to try to make some universal, maybe more enterprise grade solution for
Yeah.
this?
Yeah, what I would do today is go to my laptop and run the admission controller implementation that I have for Q. But that doesn't help. I still need to submit it. There's a CL out there. You can probably patch it. So I did give a talk at what is it, OCS conference a few years ago, where I demonstrated how a general the Q tooling layer, which is a whole separate part of Q, like workflows, where it takes HTTP requests and then basically allow you to implement at any kind of admission controller quite easily. And I actually show some dynamic admission controller where the values, the constraints even vary based on who is doing the request and things like that. Yeah, you can show that next slide. That's another interesting one. So here you see. So one thing, interesting thing about the limit range example is that it also shows a little bit the limitation of Q itself and why we are moving a bit to this like Q labs and what were the problems we're trying to solve. Because on the one hand, it's good if we, to catch things as early as possible and to move it left. But the limit range is actually quite an intricate thing, right? The way it works to encode it in Q might be a bit cumbersome. So sometimes it's hard to move the validation logic into Q, right? So sometimes we want to say, okay, we have this function here that we can call, like it could be HTTP request or some binary to run. Why don't we let Q run that, right? Validation is just a function in the end. So we are working on having much more generic function support in Q where you have for foreign function support. So there it would look something like this. So here we could say, okay, within these places within my configuration, so whenever you discover a deployment or a pod, I want you to check, right? If we're validating our configuration, I want you to check by actually doing a live call, to this cluster as a dry run to see if it validates, right? So as an alternative to writing it in Q yourself. So this is so another aspect where this becomes relevant is so this allows you to catch right if you're making if you're specifying too much memory for your container, but on the other hand, the other side of the problem, the people writing the limit range, putting the constraints of the limit range, they also need to know, okay, what potentially who are we going to affect by this, right? So that's another side of the coin. So that's also something we want to address, but we'll getting a little bit ahead of myself here. But the
So
dynamic
I know this is
admission
coming in the
control,
future, but this to
yeah.
me is like one of those game-changing components. Just the nature of kind of platform engineering as a whole. There's going to be weird things we do to validate issues. Like we have a production outage and there's a thing we never want to see again. It's maybe some arcane thing. But the ability to have a function just call out to some existing validation engine that runs in parallel. I guess the question I would have here is, when would this run? Would this run after Q? kind of makes adjustments to the config and as a last validation step, call out to this function, or would it run before Q does its thing?
That's a good question. So validation in general, if it's written as a validator, it's run after the validation. But with the way we envision functions within Q, it's actually interleaved with the evaluation.
Got
But
it.
one thing that we want like we want to be able to support is to basically say some of these expensive validations, you can turn them off, right? So you don't necessarily have to run them because Q is very composable. So as we're saying, you can combine things in any order. So you could imagine that these policies are in a different plane, if you will, different layer that we say, okay, we're gonna either include this or not include it, right? Like you don't have to linearly describe all your schema and all your rules. We can combine them in any order, basically.
So Fred has a question here. Is that not violating the Hermeticism rule for Q? I guess everything should be self-contained, everything should be here. Does that violate the philosophy of Q?
It's a very good question. So generic functions, yes, that will violate it. Validation rules, validators, not well, depends how you see it, but not necessarily, right? Because they will either fail or not. They will not contribute new values to the output. Um, but we do have in we're planning for the evaluator to do support non-hermetic functions where you would have to explicitly enable that. So that there is still a strict separation between hermetic and non-hermetic, but at least allowing you to do that and also have a good understanding what it means at all within Q to do that.
I think it's a great question, and that's a question from someone who's clearly very familiar with Q already, where they value that hermetic nature, where they know it cannot have any side effects. And just to emphasize a point that Marcel made there, this would not be on by default. This would have to be explicitly enabled.
Yeah.
You would almost have to sort of pass in like a capability to say, I want to allow this. So for those people who value that hermetic nature of Q, because Q is used in some very sensitive environments, and you definitely don't want to have side effects there. And so that we're not going to compromise, but that ability to enable it when you need it, it is something we're working on.
So there's another question. I think you kind of answered it, but maybe we can give a little bit more detail. So the question is, can you touch more on the whole validation? I want to be able to call out to some Go code for more complicated validation. Is there something like that that will eventually address it?
Yeah, that really just builds on what we were talking about there with the foreign function aspect of it. And so we're working on in the open source part of Q, we're working on what that needs to look like as a primitive, so that we can enable. It doesn't matter, as Marcel said, it could be some HTTP call, or you could be running some sort of binary. However it's specified, you're just making a function call. And if you enable that, as in you say, I want to break this hermetic seal here, then that will be possible. So the same answer applies to that Go function.
The other question that's came in here, and I think a lot of people looking at this say, all right, great. One of the other big configuration challenges outside of validation, and we're going to also talk about cross configuration validation and where this thing is going. So we talked a lot about Q that it does today. We're talking about some of the things that it needs to do tomorrow, but we're also going to be talking about some of the things that the Q Labs team as a company need to build, like what we need to do beyond open source. So not abandoning open source, but things that are not appropriate for open source that need a little bit more thought, a little bit more. In some ways, it feels like there's got to be a control plane on top of all of this. So, whereas Docker is a good node solution, Kubernetes is a good cluster solution. And it seems like there has to be something that sits on top that can now start to give people workflows for doing some of the stuff we talk about. But one of the big issues that comes up a lot is drift. So, one of the questions in here is like, hey, is there anything that Q can plan to address configuration drift? And I think Jace responded to this in the chat. He doesn't think Q should do this because other tools may be able to do something like this. Maybe, Marcel or Paul, if you want to talk about configuration drift a little bit, and then what's Q and Q Lab's stance on configuration drift, and should it be handled in Q itself?
Yeah, I don't think it should be handled in Q itself, but it's definitely something we want to address with Q Labs or with the product. Um, and really, so the product that we're talking about is Q Labs. One of its key attributes, if you will, is that it's able to consolidate and able to resolve conflicts, if you will. So to detect conflicts and basically get to a consensus. So basically point out the conflicts and basically steer people towards resolving those conflicts and reach a consensus. So yeah, so this is much more of a UI component also, so that's why it's more of a non-open source thing.
All right, let's move on to, I think a lot of this was, and we have a lot of slides here. There's good questions here, and I think there's gonna have to be tons of follow-up around this. But let's maybe go to slide 17 to really kind of set the stage for the next part of this conversation. There's this vision that people are going to have different configuration engines, whether explicitly, where I know a lot of people will use Terraform for all low-level infrastructure, but then use Kubernetes or Argo CD for the application layer. It kind of makes sense because those two things have different life cycles. Or maybe you're just using GitHub Actions, and that automatically forces you into a new config dialect or tool. And again, you could try to use Terraform to generate your GitHub Actions. There are people doing kind of things like this, but ideally, you're going to end up with all these things. And now there's this gap. And maybe, Paul, talk a little bit about that gap between doing all the things we just talked about for this various set of configurations and what Q can do to, all right, how do we manage this thing as a holistic whole so that way we can actually manage production?
Yeah, so I think the tool each we talked about various aspects of what Q can do as a tool, and the open source tool provides things we talked about today, plus a number of other. Marcel sort of hinted at the workflow side of it. But what people are left with using the open source tool itself is plumbing all this together, is working out how to stitch it all together. And that actually is a big job in and of itself, where actually there's real value in pulling it all together. And this is what we're moving on to talk about now. I think there's a number of other sort of key points that are missing from like a homespun solution like that, is that you would then also have to come up with some means of actually creating something like an audit trail. So if you're able to pull all this configuration together, how and where are you auditing this? Where are you writing it to? Are you able to answer the question, well, what happens if we change this value here? Or is this piece of data valid? Or if you're looking at a configuration, how did we get to this value here? And so that's really this sort of space where these are the key kind of operational questions that people need to be answered on a day-to-day basis. And as I said, from an audit perspective as well, to know what your configuration was at any point in time for all of your systems, there's real value to that, not least because you can then have some sort of guarantees of consistency between different parts of your configuration. So that's the gap. Q has got the good building blocks here, but actually it all needs to be pulled together, as we talked about before, into one sort of complete system.
All right, let's get to slide number 19. Maybe we'll show people like a real world kind of problem here. So this one is what I call the cross config problem. And again, this is not as contrived as most people would think. Most people will use things like Terraform to create things like VPCs, firewall rules, to set up like a cloud account, whatever. So these are kind of what we would call like bedrock infrastructure. And in this example to the left, this is like creating a node pool in something like GKE on side of Google Cloud. You can imagine this working for any cloud provider, by the way. And here we're specifying like a node count of 10. And on the right-hand side, you're seeing a typical deployment in Kubernetes that has a replica count of 10. So if there's enough compute resources, 10 copies of this pod will run across 10 of those nodes. And that's going to be enforced by this anti-affinity policy circled in that red box there. So that means, hey, we need 10 to 10. And so everything feels one to one. And if you're the one person at the company writing all of the Terraform and all the Kubernetes, you can probably keep this in lockstep. Next slide. But here's what tends to happen. These must be the same.
Oh,
And if
sorry.
they are the same, you can keep going. If they are the same, you can just use Kubernetes tooling and Terraform tooling to kind of get not necessarily validation, but hey, they're green, everything works, everything's in check, there's no drift between the two. And most people, this is exactly what you're doing. You could be doing this manually, or you could be doing this in some CI/CD pipeline, You run these tools and they both say green. Next slide. But then something like this happens. You want to reduce the node count to 7. And so all you do is touch the Terraform, but you do not touch the Kubernetes, and you run the same tools again. So if you look at this page, you may see the error already, but when you run the tools, they're going to say, look, Kubernetes has uh, a view that Terraform is fine. It is unaware of what Kubernetes is doing. And in many ways, that's kind of by design, right? Like Terraform predates Kubernetes, and Kubernetes wants to be independent so it can move on a different life cycle. But you will get no hints that there's anything wrong here, and they will both turn green. So for you all that has spent a lot of time with change review boards and validation inside of your CI/CD pipelines, you're probably going to say that this is fine, and so your tooling will agree. But then here's what we end up with when you go to the next slide. At
Right.
runtime, on maybe slide 22, I think we skipped 22.
Yeah, big button. Yeah.
Yeah, this is where you're going to start to have a problem. So you're in production, you just did the deployment, and what's going to happen is Kubernetes is also not going to complain unless you look at the fact that it doesn't have home for 3 other pods. So now we have this, some people will call this a configuration drift. These things have drifted apart. Some people would say this is an error, that these things should match. But where is it described that these things should match? Nowhere. Maybe someone sees this in production. Maybe they're watching the warnings coming from Kubernetes that it can't find a place for the 3 other replicas. And maybe you're not able to handle as much traffic. So maybe your customers will complain that there feels like there's an outage because you're no longer able to handle 10 replicas of capacity. So think about the on-call scenario here. You wake up, you do not care about Kubernetes or Terraform because that's handled by a different team. You look at Kubernetes and you see 10, right? So you're like, everything is fine. You look at the events, and Kubernetes is complaining there is no capacity for the other 3. You may then manually scale the nodes, right? Just using the Kubernetes API. Now there's 10 nodes. Someone runs Kubernetes or Terraform again. Maybe you have it in a loop, and it's back to 7. You will be going back and forth. You will have the pleasure of doing a root cause analysis, and then you'll build some custom tooling here. This is what most people have done over the last decade, a very common problem. And then now I want the QLabs team to take over because there's a vision. And I think if you go to slide 23, there's a vision where we want to be able to have the tooling detect this cross-configuration incompatibility in the way that gives feedback much earlier in the process, ideally at pull request time. Hell, ideally when you're typing in that configuration change in your IDE, you're able to connect to something that doesn't exist yet that will give you the feedback necessary to say, hey, if you do this to Terraform, there's another thing that disagrees with this change and will be impacted. This is an invalid change.
Yeah, so I think we can, if I just skip forward a couple of slides here, we've just got another instance of a cross-config problem, just to point it out, where we have some sort of drift or conflict between a firewall specification and Nginx config. As Kelsey said, what we're really looking for here is visualized nicely here, is that instead of treating these as 2 separate validations against the schema, Terraform schema, against Kubernetes schema, whatever it might be, we need to actually combine these 2 in some way and be able to represent the rule, as Kelsey said, that requires and enforces that 10 equals 10, or whatever, that the node count equals the number of replicas. And so that's the vision, is that in this situation, instead of just treating each configuration as a silo, it's rarely the case that configurations are silos. And we're just showing one example here, but there are many others, particularly when it comes to app configurations as well, where we just can't encode these sorts of dependencies today. And with Q, you have the ability to encode these things. And the vision we're showing today on the configuration control plane is that not only can you encode them, but you can then register all of the aspects of your configuration so that this is managed for you, validated and audited, so that you actually know that you have a consistent configuration across your organization.
And I think this is probably going to be the big leap forward for a lot of people. Like when Kubernetes came out, in many ways, I felt like it was a big leap forward for Docker itself. Docker did really well on a single machine. It had a view of a single machine, but Docker didn't have a view of 500 machines. That requires coordination, right? This is where you get into that overlord pattern of having something at the top that has um, a richer rule set, a richer way of defining relationships between things. So apps no longer belong to nodes, they belong to the cluster. And so in this view, Q itself, and then the first question I asked Marcel when I saw like this being the vision was, where does someone specify the relationship between those two values? Because as someone who's worked at Puppet Labs as an engineer, I worked on Core Puppet where we had this DSL, getting values from the external world, resolving these templates. And I can answer this question if you told me everything was written in Puppet, one configuration language. I can probably do something like this. But when you're talking about separate tools with their own schemas and ways of doing things, all bets are off, and now you have to have a different solution. So maybe Marcel, talk to how you would even think about approaching this. And just to be clear, this is the part where we justify the existence of Q Labs, the company. So beyond Q, the project, what value is Q, the company, going to bring to this whole scenario that's going to require a lot more than what I think is going to be allowable or acceptable in just the open source community where we want Q to be independent, composable, people can build their own tooling. How do we think about this problem from that standpoint, Marcel? Like, how would we even describe this kind of graph?
Yeah. So if you saw earlier this example where we put multiple Kubernetes objects into the same namespace. So this is basically the same concept. So instead of having just Kubernetes object, we're now going to place anything that can be relatable to each other into the same namespace. So theoretically, you can do that with Q proper. This gets a little bit tricky though, because the more you start putting it together, the more you have to, sort of design like where does everything get placed. Also, as you mentioned before, the Terraform might be set up by a different team than the Kubernetes. So all of this needs to be coordinated, right? And this is where the vision comes in for the configuration control plane, that it provides you the tools and the coordination points, if you will, to allow people to easily place all these configurations in this namespace. And then basically the configuration control plane will make sure everything gets translated to Q. We'll put in all the validations, everything will get its place. And then basically by evaluating that, you will cross-validate everything. That's essentially what it's all about. But it's really helping people to make that placement, because that's kind of messy and it requires quite a bit of orchestration. And yeah, we believe we can make that much easier for people.
Now, this is where I would like to dive into the details of this proposed solution. I'm going to take a question here first because, of course, people have some questions around, first question is the non-open source tooling going to have private constructs in Q, or will it be built on the non-private internal API as the open source one? So, like, how are we going to layer this? Is going to be some magic in open source Q that no one else can use except for Q Labs, or are we going to be building on top of the things that are just accessible by everyone?
Yeah, the latter. We do really want to have a strong core where any of the constructs are available to others. Um, so an example is the functionality, right? Like that's really like just part of Q core. Yeah, so everything all the core mechanisms will make it into Q.
I'd say
And
though.
Richard has, go
Oh,
ahead, Paul.
sorry, I was just going to say, Kelsey, just to offer a sort of a counter example to that, and it builds on an example from earlier, where a company approached us and said, "Well, hey, we have this custom configuration dialect in-house." Now, in that situation, it's not even possible to open source that part of it. So that encoding for that custom configuration language is obviously something that sort of sits very squarely in the commercial side of things. And so I think we've tried really hard to make sure that within the open source side of things, we have those relevant building blocks. And as Marcel said, Q, it will be at the heart of the configuration control plane. And using those same primitives, we'll be building the configuration control plane. But Q is an open source project as well. absolutely exists for others to build tooling on top of open source Q, and that's where the Go APIs, etc., that have existed almost since the very first day have enabled folks to build their own tooling as well. So there is a very clean split, as it were, between open source Q and the non-open source world.
And this seems to follow the Kubernetes-like model where Kubernetes has APIs for doing things like RBAC, which allows you to kind of build a native solution inside of Kubernetes itself. Or if you're a cloud provider, you can integrate your own IAM, but the APIs to do either are the same. And
Yeah.
so I think that's just good engineering design, by the way. As someone who tried to maintain private versus public APIs in a single binary, it's a nightmare. Nobody wants to do that. So I'm glad we're not doing that here. But then I think we get to Richard's question, which is probably the one that, someone's that been doing configuration management in some form or another for the last 15 years. This question, I think, hits home for a lot of people probably watching this right now or will watch it later. How do you all imagine organizing your configuration to benefit the most from Q? It seems like a global monolithic configuration across all configuration domains might be preferable or even necessary as opposed to splitting configuration up into separate independent silos. How do you imagine how do you manage complexity in this world? Maybe we
Yeah.
all should take a shot at it. Start with Marcel and then Paul, and then I'll go last.
Yeah, yeah. There's really many facets to this. So first of all, I like to make the observation that in general, if you want to define configuration for something that has a schema like a Kubernetes object or whatever, that's easy, right? Like identifying which schema to apply where, that's the easy part. What's hard is really putting it in this big, overarching namespace that can get very complex to manage. So I realize that that's not something we can always do, even if you might need to. But there are several ways. We haven't figured out exactly which way to do it, but there are several ways that are quite easy to switch between, and maybe we can even do any of those. But one way would be, for example, to make all the objects that are available. So first identify them by their type, right? Like make this available and then allow people to compose namespaces for all the objects they need and apply their constraints. So that could be set up within subgroups, but you could also imagine like using the bidirectional nature of Q, right? Where you can say, okay, somebody has defined this namespace here with certain constraints. Now and it could be multiple namespaces with all constraints on the same object. I'm now worried about this object. Tell me what constraints apply to those, right? Like we can just compute them in the other direction. So long story short, because of the flexibility of Q and the composability, we're actually quite flexible in how we can index these things and how we can compose these things and discover the constraints, even if they're built by another group completely independently, we can still identify that and merge it in and cross-correlate it.
Paul.
Yeah, I think I'll offer a slightly different take on it, but to agree with the same point. I think it's a really, really good question. If you imagine starting a project from scratch or starting a company from scratch, that's potentially where you're faced with that question of which approach should we take. But that's a very unique situation to be in. The reality is, I think that people are dealing with an inherited situation where perhaps things get bolted onto the side. And actually, you're trying to manage and orchestrate that kind of scenario where it's not even something that you wrote to start with. And I think that's one of the key bits of feedback that we've had from folks who've used the open source queue is that they can iteratively start to build up validation for things. And in exactly the same way with the configuration control plane, you can iteratively start adding configuration to the configuration control plane and iteratively start adding these sorts of constraints between configurations to avoid this cross-config problem. And most critically, you can do it without, as we've sort of indicated here, not having to convert everything to Q. Notice on the left-hand side here, we're still consuming JSON and YAML. You might even be consuming JSON schema as a means of validating that JSON. So it's about meeting people where they are rather than saying, hey, you've just got to change absolutely everything here. Just keep what you have today and then just iteratively improve things as well. And so I think that also is some sort of comfort factor in that there's no big bang switchover. As Marcel talked about the example from the financial company earlier on, you can iteratively improve these things and gain a lot of value out of doing that. So you don't even need to be committed to one answer or the other there. You'll sort of find yourself on some sort of spectrum in between them, I think.
So I'm going to jump in here. So for context, I'm an advisor to the Q Labs team, have been for a number of years. I know each of these people pretty deeply at this point. And there's something that we do that I actually get a lot of benefit from, which is having this brainstorming session around design and value that you can create. So from an engineering standpoint, like if I were to give my input here, I think the thing that's going to be the most impactful are the workflows. So think about it today without any of the stuff that you see on the screen, without Q at all, anything we talked about today, how would you do it today? So today you may check in your Terraform in one GitHub repository managed by one team. You may check in your Kubernetes configuration in another Git repository managed by another team, or hell, even separate teams. But either way, you now have these two destinations where config lives. And in that moment, you're probably going to come up with some organic workflow for dealing with these configs. For some people, it's going to be as simple as pull request and someone reviewing them and saying they look good, and then merging them. And then CI/CD does its thing and calls Terraform in one instance, or CI/CD or Argo CD, if you're using tooling like that, will pull the configuration files from Kubernetes, maybe bind some values. There's another good point that was brought up in the chat. A lot of these configurations are only in like a 90% state because without their values, they're not actually ready to go. And so what we end up doing is trying to figure out what is the base set of things that we can put in place, and then we combine them with the environment specific configuration, the key values, like what email server to use, what IP address to bind to. So I'm going to set that aside for a second. So the dream workflow that I could imagine would be, if you notice here, we're not just showing you that it's JSON and Terraform, we're showing you that there's URLs here. And so those URLs allows a team to kind of register some repository that should be watched, something that we should probably monitor. Because if you zoom out over this whole thing, I think the holy grail for configuration, you're trying to get to a snapshot of the global config that works. And that snapshot could literally be you in production, like, mudging things until it works. And then everyone says, all right, that's it. Don't touch anything from this point on. The firewall is configured correctly. The database is configured correctly. Kubernetes is configured correctly. Terraform is configured correctly. Just leave it alone. It works. And only when people start touching stuff is when we find out that we have an incompatibility. So now the goal with this intermediate step is to say, can we capture this meta snapshot of everything in a single place? And I think what you end up with is the things we talked about earlier. When someone goes to their Terraform repository, maybe they don't even know that the queue control plane is in place, and they make a change. In their IDE, they're getting this feedback from the same thing in the middle that says, hey, um, you can't do that because there's a constraint in place that you have a dependency, that if this number changes outside of the scope of this other thing, that won't work. So for that person working independently in isolation in their silo, they get this feedback saying, you probably don't want to do that because it's not going to work. It's probably going to break something. And the same is going to be true for people working on other aspects of the config. And then I think the real value becomes what's required for someone like me or you to come to the thing in the middle and figure out what the hell is going on and to express these dependencies, right? How do I go in and say, this field in this deployment is related to this field in this Terraform object? Lock that in, and then you can imagine after I do that bit of work, if people start doing stuff, like the Wild Wild West will continue, but now I can go to one place when I wake up in the middle of the night on call and say, I see it. Someone changed the Terraform and pushed it through. And now I can see what's going on here and resolve that. So I don't think there's going to be magic where it resolves itself, but enough clues where we don't all have to go on a scavenger hunt to figure out where configuration is coming from. And then last thing, you got to correct me if I'm wrong here, Marcel. There's a future where this thing in the middle could push things to like CI/CD endpoints that are saying, hey, You take it to the tool that you want to use going forward. It could be Argo CD because maybe it needs to roll things out over time. But there might be another world where you say Terraform apply URL queue endpoint that has the resolve config that is safe to use versus relying on a GitHub repository changing from underneath you in an incompatible state.
Um, yes, absolutely. Yeah. So thank you, Paul, for going to that slide. Yeah, that's absolutely the case. So the idea is that especially if you have multiple sources and including dynamic sources like etcd, it becomes hard to see, okay, what does it mean to have the current configuration, right? And the configuration control plane has some idea about chronology, about of changes and all the things where you can really say, okay, here we have a snapshot from this situation, considering all these sources and this knowing what has been sent to deployment and stuff like that, where you really can say, give me the way things were evaluated at that time, right? So that you really have reproducible results. And what we didn't mention maybe in the beginning, but one thing that precipitated all of this, or one big part of this vision or motivation for it is that more than half of the outages that we see are usually related to configuration. And then very often it's cases, I've done some research in this where, or quite a bit, where you see that it's not a single, simple value like that's without outside of a range. It's really like these violations of policies that you do not catch that were known at the time of deployment, but that were not validated at the time of deployment. That's a quite significant part of the outages. So that's one part of it. But the other part of it is once you do have an outage, it's also very valuable to know very quickly, okay, why was this value changed and why did we end up in this situation, right? So that's where this configuration control plane comes in. So it's combining the sources to have reproducible results, but also to have a very meticulous record where we can say which value changed where. And this is important, especially if you use a lot of templating. So one change in a template can cause thousands of changes across configurations, right? Like even, for example, if you have this node count change in Terraform, that affects the replicas somewhere else, right? So by having this sort of view on this and basically know what are all the relations between everything, we can sort of see, okay, this value that we have here was basically influenced by these and these other values. It was changed at this moment. And all these things you wouldn't necessarily know from the templates itself, right? Or you would have to know for where all the repositories are. So really the configuration control plane tracks all that and keeps track of the relationships and of the individual value changes, right? At the individual value level.
We got a good question that just popped in. Can you clarify what you're calling input sources? Are these Git URLs containing TF YAML files in Q or Q bundles that were pushed to a registry somewhere in the past? I'm looking forward to seeing the details and mechanics of how this will work at the end of the day. And this is a conversation we all had just last week around, people are used to pushing these things to their dedicated Git
Yeah.
repositories. So what
Yeah.
then makes its way to the control plane?
It's a great question. So here, if you look at this diagram, you sort of read it left to right, where there's an input coming in from the left and an output on the right. But to the specific question about input sources, broadly speaking, there are two kinds of inputs, but not to sort of try and be complete in that explanation. So if you have something like a GitHub repository, you absolutely could register that with the configuration control plane and say this URL, and then you were going to need sort of further specification of the configuration. You might say, for example, well, this is the default branch within that GitHub repository, and we do releases by tagging with semantic versions. And if I can just pop back to the previous slide to talk about this a bit more, what that enables us to do, if I can just go back to the previous slide, what that then enables us to do is actually something that Marcel talked about, which is this change management side of things. So now, having registered that GitHub repository with the configuration control plane, we natively have some concept of as well of saying, well, if someone wants to change something within that GitHub repository, they're likely to do it via a PR, for example. So we will know when a PR is created, and we'll also then be able to say, oh, hey, someone's trying to make a change targeting the default branch here. And this picks up on the example from earlier, where they're changing the node count. And the configuration control plane will be able to say, coming back to what Kelsey said earlier on, well, hey, I've got this overall view here of all the configuration, and I can see that this change would violate this change would violate this constraint, excuse me. And so that's where it sort of depends on the kind of input. Some inputs will actually be more of a stream of events. So some, like a GitHub repository, will get a sort of a mix. We're either poll or we'll get some sort of event, depending on what it is. And Marcel talked about etcd being a different kind of beast as well. So input sources are going to vary in their nature. Some you might literally just have to poll because you don't have any mechanism other than sort of checking every minute, has this changed? Others where there are events that we can hook into, then the configuration control plane will be driven by those events and will be responding to those events accordingly. As I just said, for example, where there's a PR coming in, we know to consider this a change to a potential change to the system. It must be validated and the results pushed back to the PR, for example.
You know what's crazy about this? Every configuration management tool, at least the ones I've contributed to Terraform, I've worked on Core Puppet itself, and of course Kubernetes. They all do this in some way. If you change a variable, that will tend to cause the tool on its next run to recompute the config to do its thing. The same is true of Helm. And so when you think about having a Terraform object on the command line in a file system, and if you run TF on it, if you change that config, maybe something new will happen the next time you run if the config is different than before. What we're trying to do here, I think, is say, hey, let's not just register the source code because I think that limits what you can do. It forces people into weird workflows as well if you do it that way. I think the smart thing here is saying, if we report, if we support a repository as an endpoint, when you issue the pull request, it's just another event that can trigger a recalculation of things and give you a feedback loop in context. I think that's the key here. So you see this a lot. If you ever have to ever like review someone else's code, you have to go get the state of the world plus their commit and then combine it locally and run all the tests. Your CI/CD system does this, for example. I think we're trying to do the same thing here. And it's something that I learned new today was that I didn't think about it, but it's obvious. etcd is different. etcd may be a thing that says, I have a key value that's being referenced somewhere. And if that key value changes, then that may trigger off a recalculation of the config as well. And I built tools like this, like compd does this, for example. You give it a set of templates, but it watches etcd to decide when to recalculate. The problem with things like compd is they're doing it on the live system. There is no intermediate state where you can view what would happen, no concept of a dry run to gate these changes from actually going out. I think this is a huge maturity for configuration management in general, acknowledging that we probably do need to have a universal type of control plane where we can mix these things and have the triggers have a holding place before they start impacting production. Right now, all of our tooling just does stuff once things change. We probably want to have an intermediate layer that allows us to buffer that change until the policy agrees.
I think just Kelsey, if I can jump in on one thing is to say, just as the input sources can be different in nature as well. I think on the right-hand side where we, so when you sort of come out of the right-hand side of the configuration control plane, that's where we know we have a valid configuration. All of the rules, all of the constraints have been satisfied. We have something auditable that we know exactly what contributed to a configuration value, so we're safe. And so it's at that point that we can start to say, well, this part of our configuration graph needs to go to a GitHub repository. And we can create a commit with that part of the configuration and just push it as a separate commit. We might push it to an OCI server as a new image, for example. You can see a slightly weird one up on the top of the right-hand side there, which is the Visual Studio Code icon. as well, we're going to have this ability, and Kelsey hinted at it earlier, of making a change in an editor where you are actually changing a configuration, much like the change request we saw. But within the editor, you're saying, well, I'm changing this configuration. Is it valid or not? And so the editor is then also getting told about these live changes in configuration that would otherwise have caused that might have caused a violation of the configuration that's being edited, for example. So there's different beasts on the right hand side as well here. Some where we will push, and other situations like the LSP in the editor where they will actually sort of be doing querying and validations themselves, much like a sort of an API. So the configuration control plane on the right-hand side will absolutely offer such an API for that real-time sort of querying.
We got about 10 minutes left, and David and Richard, I think, have come full circle, which I think the goal of webinars like this is exactly this. David mentions I've been building this configuration control plane with Argo workflows, and I just can't wait to buy it off the shelf. Richard says, David, the same. They've been doing this in GitHub Actions. And again, I think this speaks back to the workflows. We've been building bespoke tooling around this problem for a very, very long time. And it's hard to articulate it to people because we just make it work for ourselves. And the next company, we build it over and over again. I think what we're trying to do now is standardize the philosophy around this. We need a buffer for configuration because that's the only way you're going to be able to resolve all the things. And then once you have that buffer, you know that the config is going to continuously change. So you're going to have a continuous feedback loop. And just changing config isn't the end game because it has to live somewhere and it has to be debugged. And so as we move towards configuration as data, this starts to get much easier for tools like Q to actually do this and actually live up to the promise of saying, can we do this across all configuration and not just one or two particular tools? We asked one more question from Kevin. We're going to end here, then I'm going to let the team wrap up a little bit because we do have some ways for you to follow up and maybe get in contact with us because we're still taking the input for the design phase, right? So there's things that you want to do, things that you want to see. You still have time to influence that. So last question is from Kevin. So when you change the node count, you also have to adjust the replica count. Um, sorry, just replica. How does the control plane know if it has to apply Terraform first or the Kubernetes config for this example? How does this work with GitOps? Will I have one Git repo for the configuration control plane and GitOps repository? Where does the control plane push for Terraform right after? Wow, there's a lot there. And I can actually see this because I was describing this particular workflow. In this scenario, one thing that Kubernetes does a good job of is says you can apply Kubernetes configuration, and if there's not enough nodes there, then Kubernetes will just try forever. That's the whole promise theory thing. So if you go from 10 to 7 on the Kubernetes side, and you've done something different on the Terraform side, well, Kubernetes actually has a good way of resolving itself, right? So it will stick to this configuration, and over time, it will resolve the world. So Kubernetes will just keep trying. So if you pull, in the case of our presentation, if you go from 10 nodes to 7, well, what Kubernetes is going to do is sit there and try to get back to 10 whenever that's possible. So whenever you run Terraform again to get to 10, then Kubernetes will say, all right, I see 10 nodes, and I will go ahead and spread out the rest of the pods. I think that's going to be key for a lot of these systems because if you get into a world where you really do have to programmatically run one tool first and the other, this is why we're still going to need tools like GitHub Actions or some orchestration tool that says apply this config first, then apply this other config. For example, you need the IP address to exist before you can bind it to a DNS entry. That's always going to be a real thing. So when I think it comes to orchestration, this is why I think in this control plane, you may send that config to its destination so that orchestration can take over. And I think that's probably a good place to live. Hey, Q has resolved all of my configs, all of the inputs that I want. I want an IP address in US East 1, and I would like a configuration firewall to be in the same region. Those things must be compatible. But then the orchestration of when to run one or the other, I think that then falls on the orchestration tool to run one config, wait for it to finish, and then have the other config run. Hopefully they'll be compatible with each other versus them trying to do the same thing in two different regions. That would be bad.
I think just to briefly add one thing there, Kelsey, is that as well, where there is sort of like this runtime realization of values as well, it comes back to a question somebody asked earlier on, where sometimes we have sort of incomplete configurations. I think as well that it's an area to explore as well because to be able to express a relationship and say, oh, we need an IP address from here, that for a given configuration, we might not actually have that. But when we have it, if there's some sort of feedback, then that's when we can start to get that sequencing of things and just that have that be expressed as a relationship within the configuration control plane.
I think we should wrap it here. Man, I think the majority of people, like 90% of the people, stayed the whole hour and a half. So appreciate you all for staying out with us. I think we have a contact us slide, Paul, if you want to bring that up, so
Yep.
people can get involved. We'll leave that on the screen. And I'll give final words to Paul and Marcel, if they want to add anything or what people can expect going forward.
Yeah, I'll start maybe and then let Marcel, as the creator of Q, finish. I'll just say a huge thank you to those people who have been part of the Q community to date, because it's actually been that experience of interacting with folks on how they use Q, what works for them, that's actually helped to shape the open source project. So thank you for that, and we look forward to working as we are already with a number of you on what the configuration control plane could and should look like for you. So
Yes, same here. Thank you to all the very loyal contributors and users of Q. Some of them have been with us for a very long time. Um, yeah, it's really exciting to now finally go to this next level, where we really try to make Q like a professional, like tool where we really realize the vision of Q where it should go. This is just the beginning. We haven't really talked about any of the workflow stuff and all that stuff. That would be a, next phase. But for now, we're focusing on this, and this is very exciting. Many things we didn't get to talk about, but
yeah,
there's a lot to talk about. Yeah. So I
So the
hope
thing
to
I
see
learned
you
today
also.
is
Yeah.
Yeah,
Sorry.
one thing I learned today is we probably need to do a lot more of these
yeah.
in finer grain resolution. It seems like the Q community is super strong. I also think we need to give a forum where people can share what they're doing with Q a lot more often. And this really feels like the year before Kubernetes was announced to the world. I can imagine people sitting back, seeing the success of things like Docker and what people were doing for single node solutions and all the custom tooling we were building around Docker. Me being at CoreOS at the time, we were also building that custom tooling. And then one day Kubernetes comes out and it sits above all of that. And it wasn't like it was perfect and finished, but it was an invitation for people to bring in things. And that's when I became a contributor. We started building, you know, other controllers, integrating with things like Let's Encrypt, etc. I think we're now at that moment where we don't have all the answers, but we know there is a better architecture for building out given the momentum that we're seeing on the configuration side. Configuration is getting easier to create. We now have LLMs that's generating it like crazy. People are generating it like crazy, but it doesn't solve that problem of, I introduced a term a couple of days ago to the team was just this cross configuration consensus. Your whole goal is to get all of your config to agree with each other, and you can do that over time in many ways, but we kind of need this middle layer to make it happen. So I'm hoping everyone kind of seizes this moment to figure out how do we take all the custom things we've been building to solve this problem and maybe push it in a more standard way, and hopefully something more standardized comes out of it. I want to thank everybody for hanging out with us. The recording will be made available. We'll include a link to the slides as well, and people can follow on and feel free to share this with people who weren't able to make it today. Thank you all.
Thanks, everyone.
Thank you.